Hi friends, welcome to our YouTube channel. In this video, we are going to discuss about the chapter Dual Nature of Radiation and Matter. It's a chapter in the grade 12 syllabus, physics. Approach of this video is we are assessing the topics and the concepts on the basis of committee examinations. So these are the major concepts and equations of this chapter which you should know to the base level for this preparation. It will be helpful for you for the upcoming Neet or JEE and SAT exams. We can go through this. What are the major topics of this chapter? Dual nature of radiation and matter. See, the nature, our universe, like symmetry. Whatever you touch in the universe, it may be either of a matter or a radiation. For example, all the objects what come across us is maybe a solid, liquid or gas or these states we have. That's matter, nothing but. And light is a form of energy, is a radiation. So either energy or matter is the constant of the universe. In this chapter, what are the basic nature of a radiation that we will analyze? And what is the basic nature of a matter that also we are going to analyze? And it's found that the matter has both the nature of matter and radiation. So there is dual nature for matter. Similarly, a radiation can also have the basic nature of a radiation and the matter nature. So dual nature of radiation also. That's the meaning of this chapter. Dual nature of radiation and dual nature of matter. That we are going to discuss in this part. See, a basic nature of matter is any moving object. It can impart energy to another body. As a basic nature of a particle. The same nature a radiation also can have. It's one of the most common example for this aspect is photoelectric effect. You might be knowing about it. Whenever the light or energy or radiation of sufficient frequency incident or falls on some metallic surfaces, it is found that some electrons are ejected out. That means you can withdraw or you can escape an electron. You can remove an electron from the metal surface by using a radiation of proper frequency or sufficient frequency. The phenomenon in which electrons are ejected from the metal surface when radiations of suitable frequency incident on it is known as photoelectric effect. In this aspect, the radiation imparts energy to the electrons. You know we have to apply energy to remove an electron from the metallic surface, from its orbits. Here that energy is provided by the incident radiation. So based on the photoelectric effect, we can say a radiation has a particle nature. That concept first we are going to discuss in this one. So there you should know about what is meaning by a photon. What is the energy of photon? What is momentum of the photon? And the photoelectric equation. This is a major part of that idea. The next part will come to a wave nature or radiation nature of the matter, a particle. So first we can assess what is the photoelectric effect and its related terms. So photon, the word photon actually stands for energy packets or quantas. The particle theory or corpuscular theory put forward by Isaac Newton says that all the radiation, the light is made up of packets of energy, continuous flow of packets of energy called photons. So photon is fixed packets of energy we can have. The energy of photon is given by E is equal to h into nu. Nu is the frequency which is given by c by lambda, where c is the speed of light and lambda is the wavelength. H is the Planck's constant. So every radiation is made up of photons, we can say is a continuous flow of photons. Its frequency is nu and Planck's constant is h. Then energy E is equal to h nu. That can be written as hc by lambda. It will help you to find the wavelength of photon also or energy of the photon if frequency is given. So this equation will help you to calculate that energy and frequency, vice versa. Of course, the unit is joule only. Energy is SI unit is joule. Frequency is hertz or per second, and lambda has the unit meters. The Planck's constant h has the value 6.63 into 10 raised to minus 34. Now, what is momentum of a photon? Momentum, you know, is a product of mass and velocity for a particle, moving objects. So momentum of a photon is given by P is equal to E by C. Energy is h nu by c is there. So h nu by c, we have the momentum. And the moving mass of photon, suppose photon is the movement, the mass m will be equal to E by c square. This we are getting from famous Einstein's equation, E is equal to mc squared. So m is equal to E by c squared. Here energy is given by h nu. So h nu by c square will give you the mass. From there only we are getting the momentum P is equal to h nu by c. So h nu by c square is the mass into c, the speed. If you give, you will get the momentum P. So P is equal to h nu by c. So these are the basic characteristics or the terms related to a photon. So mass of a moving photon you can find, momentum of moving photon you can find, and energy of photon also you can get it. I hope you got this concept. Photon, what is it? Now, photoelectric effect means when these photons of suitable frequency or sufficient frequency falls on a surface of metal plate, electrons are ejected out of the metal surface. This effect is called photoelectric effect. The word photo stands for light, electric comes from electrons or charges, the effect. Here, the minimum frequency of the incident photon which is required to eject out an electron is called threshold frequency. We will represent the letter with the nu 0. If incident frequency is nu and the minimum frequency is required for the photoelectric effect to take place, that is to eject out electron from the metal surface, that's called threshold frequency, that's called nu 0. And h into nu 0 will be the energy required to eject out. That energy is known as work function. We will represent by the letter phi 0, the work function. So the minimum energy required to eject out an electron or to liberate an electron out of the metal surface is termed as work function. Two terms, threshold frequency and work function. So nu 0 is the threshold frequency and h nu 0 is the work function. The Einstein says that the kinetic energy of the ejected electrons from a photoelectric effect, K max, the maximum kinetic energy will be equal to the difference in energy of the incident photon and the work function required to eject out electrons. In a sense, we can say the energy which is falls over the metal surface is used as two parts. Total energy is constant, conserved. So two parts, one part is utilized to eject out, that means as work function. And the another part will be utilized as kinetic energy of the moving electrons, the photoelectrons, the ejected electrons. So this is the famous Einstein's photolytic equation. He got the Nobel Prize also for this one. K max is equal to h nu minus h nu 0. In short, you can write is as h into nu minus nu 0. One concept here is if nu is greater than nu 0, then only kinetic energy will be positive. And there is no meaning for kinetic energy as a negative. That means if nu is less than nu 0, no photoelectric effect takes place here. So the maximum kinetic energy is always h nu minus h nu 0. Then this kinetic energy can be written in terms of stopping potential also. E into V0 is equal to h nu minus phi 0. Phi 0 means the work function. So EV0 is equal to h nu minus phi 0. Nu you can write as c by lambda, so hc into 1 by lambda minus 1 by lambda 0, where lambda 0 is a threshold wavelength. Suppose question comes to find the threshold wavelength, then 1 by lambda 0 you can use it. The term stopping potential, it says that the maximum anode potential to stop photoelectrons is called stopping potential. From theory we can say that kinetic energy, maximum kinetic energy of will be equal to E into V0. We are getting the concept of potential. You know potential is the work done in moving a charge, W by Q. That work is equal to kinetic energy. So we can say kinetic energy is equal to charge into potential. Charge of electron is E we can say, and stopping potential V0. That will be equal to half mv max square. So by equating these two, you could get the speed of electrons, you can get the stopping potential, you can get it, you can compare both. So stopping potential concept also you have to get it. Now in this photoelectric effect we can see that one, the incident intensity of incident radiation is directly proportional to the intensity of photo current. That means photoelectrons emitted per unit second, how much they are moving through. So here we got a term stopping potential. So the concept of stopping potential gives you the maximum energy of a photoelectron actually. So the highest potential which should be applied along anode to stop the photoelectrons is called stopping potential. That V0 we deploy. Then V0 into charge will give you the maximum kinetic energy. So K max is equal to EV0. That is half m V max square. So to get the maximum speed or maximum kinetic energy, you can make use of these all the equations. You got this concept, I think. Now, on which factors this stopping potential depends? It is found that the frequency of incident radiation is a factor on which this stopping potential depends. As the frequency increases, the stopping potential also increases. But it do not depend upon intensity of incident radiation. So intensity you increase, the saturation current or photoelectric current can increase, but stopping potential do not change. That's the two concepts you have to take here. Now, and frequency is also changing the kinetic energy that we are getting from the photoelectric equation itself. As the frequency increases, kinetic energy also increases. That concepts you have to keep in mind. Now, so this all gives you an idea about the particle nature of the radiation, the phenomena photoelectric effect. We can discuss the other side now. What will be the wave nature of matter? That is the dual nature of matter. Matter has basically particle nature. Now it can have the wave nature also. Theoretically, it was put forward by the scientist de Broglie. So it's known as de Broglie's matter wave concept. He put forward theoretically the wavelength lambda is equal to h by p. Every moving objects, any moving particles, a moving electron, a moving protons, anything, alpha particle, all the moving particles is associated with a wave known as matter wave. Its wavelength is given by lambda is equal to h by p, where h is the Planck's constant, p is the momentum of the particle. Momentum is nothing but mass into velocity, h by mv. So lambda is equal to h by mv. That equation gives you the wavelength of the matter wave. So if mass of a particle is given and speed is given, matter wave wavelength lambda we can find out. Can we see this matter wave? No, it's because this h is a very minute quantity, 6.63 into 10 raised to minus 34, and m, mass of the particle. As the mass of the particle increases, lambda will be very, very small. So you won't be able to see as a wave. But electrons are not very light particles. Electrons mass is very low, so it is that concept it associated or it can act as a wave associated with it is made use of in electron microscope, the wave nature of the electrons. So for that whether we can calculate also, and v is the speed of the electron or the particle moving through it. Now this mv momentum you can link with the kinetic energy. You know momentum p square by 2m is equal to k, the kinetic energy. So by using this concept, instead of mv you can write root of 2mk. So lambda can be h by root 2mk also, but k is the kinetic energy. If energy of the particle is given, then you can use this equation to calculate the de Broglie wavelength, where m is the mass of the particle. Also we have kinetic energy, k is equal to ev0, like charge into potential. So charge into potential in terms of lambda can be written as h by root of 2mqv. In the terms of charge into potential, you can make it use of. Now for an electron, lambda can be to the level v, potential is given, that is 150 divided by v, the potential power 1 by 2, root of that much Armstrong you can make it. That is 1.227 by root v nanometers you can keep it. And for a gas molecule of m at temperature T, lambda is equal to h by root 2m kt. It is the absolute temperature. And the number of photons emitted per second from a surface can be written as n is equal to power of the source divided by energy of the photon. If you take the ratio, you can find number of photons emitted from a surface. Now, this de Broglie concept, the matter wave, was experimentally proved by Davison and Zomer experiment. In that experiment, they done the electrons ejected or scattered from a surface of nickel plate, they calculated the intensity and they observed at what wavelength they are scattered out. The wavelength calculated by two cases, by de Broglie concept and Bragg's equation. Both were come to be nearly equal, so they confirmed the de Broglie wavelength is approved. Is possible, the matter wave. That's one experimental side. The same concepts are used there, also lambda. So here you got the concepts like that. What is dual nature of radiation and what is the dual nature of matter? Basically, matter has particle nature and radiation has wave nature. In this chapter, we compared the particle nature of radiation and wave nature of matter. In order to know the particle nature of radiation, we made use of this phenomena, photoelectric effect. And Einstein's equation gave us the whole concept of what is photon, photolytic effect, and energy of the photoelectrons. Now, in the case of wave nature of matter, we made use of the concept of de Broglie concept, the matter wave concept. The wavelength theoretically we got and practically was proved by Davison and Germer experiment. We can go through some numerical equations now. Calculate the linear momentum of 3 mega electron volt photon. So energy of the photon is given. You have to find the momentum, linear momentum here. We have the equation directly. P is equal to E by C. Energy by C. Now this energy is 3 mega electron volt is given. So mega you should convert to electron volt. So 3 into 10 to the 6 electron volt. Divided by C is speed of light in free space. You know it. 3 into 10 to the 8 meter per second. In the options, answers also in electron volt per second is given. So no need to worry about it. Just you can do it. If it is to convert to joules, you should do like this way. 1 electron volt is equal to 1.6 into 10 to the minus 19 joules. If it is to convert, you can do. So this P is equal to 3 and 3 you can cancel. So 10 to the minus 2 electron volt into second per meter. Rearrange it. So 10 to the minus 2. This is the answer for the momentum. Now, if the answer should be converted to kilogram meter per second, then you should multiply with the 1.6 into 10 to the minus 19. You will get into this one. I hope you got it. We get to one more question. The question is like this way. The work function for aluminium Al, potassium K and platinum Pt is 4.28 electron volt, 2.30 electron volt and 5.65 electron volt respectively. Their respective threshold frequencies would be. We have this concept, work function phi 0 is equal to h into nu 0. So we have phi 0 is proportional to nu 0, the threshold frequency. So in the question, it is given like this. 3 work functions are given. Now their respective threshold frequencies. So work function is directly proportional to threshold frequency. So the same, directly they are also linked. So which is the highest, then according to order you have to do. So here we have for Al, we have it is for 0.28 electron volt, and for K we have 2.30 electron volt, and for Pt we have 5.65 electron volt. So in the ascending or descending order, both you can do as options. So here will be highest for Pt, then second for Al, then third for K. So Pt greater than Al greater than K is the answer for this question. So it's a simple concept only, how this threshold frequency and work function related. I hope you got it. We get to one more question. The question is like this way. The threshold wavelength of a metal having work function 2 electron volt is 6000 Armstrong. What will be the threshold wavelength for the metal having a work function of 6 electron volt? So we have threshold frequency, work function as in terms of threshold frequency we have h nu 0. That is h nu can write as C by lambda 0. So the phi 0 is proportional to 1 by lambda 0. Now here two concepts are given there. So first concept is like this way. This one gives you inversely proportional. The wavelength is inversely proportional. So first one, phi 1 is equal to 2 electron volt and lambda 01 is equal to 6000 Armstrong. That 2 is given. Now work function phi 2 is equal to 6 electron volt and we have to find lambda 02. So just find the corresponding terms are there. So phi 1 by phi 2 you can write as phi 1 by phi 2 will be equal to lambda 02 by lambda 01. This gives you lambda 02 is equal to cross multiply, that's only, so phi 1 into lambda 01 divided by phi 2. Okay, so if you solve it, it become as 2 electron volt into lambda 01 is 6000 Armstrong divided by 6 electron volt. So if you cancel it, 2 and 6 you can cancel, 1000 is there, so answer is 2000 Armstrong. That will be lambda 02. So here we made use of the concept work function and threshold wavelength. I hope you got this concept. So merely comparison way you can do this one. A question is like this way: energies of two radiations twice and 5 times the work function of metal are incident successively on the metal surface. The ratio of the maximum velocity of the photoelectrons emitted in the two cases will be. To solve this question, we have to make use of Einstein's photolytic equation. We have kinetic energy K max is equal to h nu minus h nu 0. This can be h nu is energy minus phi 0, energy of the incident photon. So in this question it is given that energies of two radiations twice and 5 times the work function of metal are incident successively on the metal surface. So first case we have K is equal to K1 I am putting will be equal to E is twice the work function. So 2 phi 0 minus phi 0. And for second case K2 is equal to 5 phi 0 minus phi 0. Because 5 times the work function is there. Now ratio of maximum velocity of the photoelectrons. So K1 by K2 will be equal to 2 phi 0 minus phi 0 divided by 5 phi 0 minus phi 0. K1 by K2 means half m V max square is there. So half m V1 square by half m V2 square. Mm cancels is equal to 2 minus 1 1 phi 0 by 5 minus 2 4 phi 0. So this all cancels. We get that V1 square by V2 square is equal to 1 by 4 or V1 by V2 is equal to 1 by 2. So ratio 1:2 is the answer for this. So here we made use of Einstein's photolytic equation. I hope you got this concept. So please go through this video thoroughly and be sure about the concepts and the major equations of this chapter. Thank you for watching it.
Bright Education Center, Medical and Engineering Entrance Coaching Center, Hilal area, Doha, Qatar. For further enquiries, contact 306000679.